Hello, I just wanted to go ahead and stop back on here and explain the chain and product rule. This is pretty basic calculus stuff. So let's start with the chain rule, where it's basically something like zx equals f gx. So essentially that's saying x is the input of gx and gx is the input of fx. That's equal to zx. So the derivative of zx, so z prime x, equals f prime gx times g prime x. So the rate of change of f as gx increases times the rate of change of g as x increases. So this is basically like two gears, right? If you have two gears and one's bigger than the other, doing this is going to turn this slowly as well. So it's accounting for both rates of change. So this can be useful for something like let's do the product rule really quickly. Product rule is pretty easy. It's like uv prime equals u times v prime, and then plus v times u prime. So like if you have like a term like fx equals 3x squared times 5, I'm gonna go ahead and turn off this like graphing stuff. 3x squared times 5x minus 10, something like this. We can set up our u's and our v's. So u equals 3x squared, v equals 5x minus 10, u prime equals 6x, okay, because it's the power times the original coefficient, and then you take 1 away from the power, which is just going to make it 1, so it's to the first. So, and then v prime is equal to, of course, this is all in relation to x, so we can go ahead and put that actually. X, and then like x, like stuff like that. Can I just, whatever. So v prime x is going to be just the derivative of that, which is 5. So this is going to be 3x squared times 5 times 3x squared plus 5x minus 10 times 6x. So I'm sure you know how to distribute, but let's just go ahead and explain the FOIL rule. First of all, 5 times 3 is 15, so 15x squared plus, and then we have this term here. The way you do this is you do this term here times this term, and this term here times this term. So 6x times 5x is 30x squared, and then this term times this term is equal to negative 60x. And that is our final answer. But we could actually do this an easier way, or not an easier way, but like to combust that a little bit more. So this, we are going to go ahead and factor that. So 15x x, and then we have 45x squared. That's what this is. So it's going to be 3x minus 4. 15x times 3x minus 4. Yeah. So that is the final answer to what f prime x is. So f prime x, it's actually, see how it's identical. So let's go ahead and turn off all these other graphs. So we have f prime x, which is this, the derivative of this, and then we have 15x times 3x minus 4. And if we just, turn this on and off, right, it's identical. The same thing, because that is how you find the derivative of a function like this. But that doesn't really use the chain rule, so we're going to make a little bit of a harder one. So if we have like fx equals 6x squared, or 6x to the third times 5x plus 1 squared. So it's two terms, so this is essentially u times x still, or u times v still. It's still going to be using the product rule, but the way we find the derivative of this is a little bit different, because we need to use the chain rule. So first of all, u equals 6x to the third, v equals 5x plus 1 times 5x plus 1. Wrap those into parentheses. And that, of course, is going to equal 25x squared plus 10x plus 1. Might as well do that very quickly, because it's a very simple distribution. Now, if it's like to the third, stuff like that, there's no real reason to. We can just deal with that later. But then we have u prime x equals then 18x squared, and then v prime x. Now, how are we going to do this? So, we could just use this and take the derivative of that, but that's not really going to work whenever the powers get much larger. So, we may as well go ahead and just take this form and break it down. So, using the chain rule, right, we can note that this is the first function, and this is the second function, right? So, this is gx, and this is fx. So, then, that would mean you do 2 times that, and then times this, because this is the rate of change of x within gx. So, times 5. Right there. So, we do 10 times 5x plus 1, v prime x equals 50x plus 10. There we go. And, of course, we can go ahead and check this. 25x squared times 2, so 50x. So yeah, it corroborates the same with this one as well. So, that's great. That's how we know we're right, because if we just take the derivative of this, which is the expanded version, it's the same as if we just did the chain rule. So now let's go ahead and lock this into our product rule formation. So 6x to the third times 20 times 50x. Please stop. 50x plus 10. Turn off these graphs. Turn off the graphs. Okay. And then we have our u prime and v prime. So 25x squared plus 10x plus 1 times u prime, which is 18x squared. So we have all our numbers here. Right? Yeah. I believe that's right. If not, then I'll just do the problem over again whenever it says I'm wrong. So 50x plus 10 times 6x to the third. So we have 300x to the fourth, because 3 plus an invisible 1 here is 4. And then 10 times 6x to the third plus 60x to the third. Easy. So that's one term down. This one's down. So now it's just this. Plus 25x squared times 18x squared. 25 times 18 is 450. X to the fourth. Then we do 18x squared times 10x, which is 180x to the third. Please stop. And then we have 1 times 18x squared, so plus 18x squared. Now, let's go ahead and check this with d over dx fx. Identical. See? We got the same answer again, except this one's much harder. But let's go ahead and, just to, practice factoring, let's go ahead and factor this down. So we have 750x to the fourth plus 240x to the third plus 18x squared. What are the common factors here? So, is 750 divisible by 18? No. Is 750 divisible by 6? Yes. So, let's try 6 first, and if it can be broken down further, we can break it down some more then. Let's go. What's 750 over 6? 125. So it's going to be 6x squared uh, 125x squared plus 40x to the just 40x, and then plus 3. Does this have any common factors? No, it does not. So that is going to be our final answer. So the product rule and the chain rule are pretty simple. They're pretty basic level, calculus stuff. Why am I up here now? Go back down there. Yeah, it's pretty simple stuff. But, yeah, I hope I could help you, understand this, even if you, are much further than this. It's pretty simple stuff, and whoever does watch this video, if anyone does, I hope this could help you, because, stuff like this can definitely be helpful just to kickstart, like, a long adventure, like this math notebook here, right? I have 100 pages in it, and I started in March, and it's all, like, calculus and Algebra 2 topics, so it's really great way to get the ball rolling, and I hope I could help you with that, and with this, and bye. Have a great day.